Hello, class. Unfortunately, it looks like I'm not going to pass the COVID screening this week. So that means for just this week only, we're going to be moving class online. What that means for you is instead of an in class lecture, we're going to have this narration over the lecture notes. In terms of participation, there still will be a small group work component, and that's going to be in somewhere in this video. So you're going to have to watch the video to find it, and it will involve posting something on the OWL forums. One thing I'll mention before we begin is I'll be going over these slides a bit faster than I would be in class. That means less time watching videos for you, but that's just so I can get these out to you in time. Due to the nature of this format, you can pause the video and go back. So if I'm going a little too fast, do feel free to pause and go back a little bit if you need to. Similarly, if you feel like I'm going too slow, YouTube does have that feature to increase the playback speed. There are a few announcements for this week, so let's get into it with that. So the first big announcement is that teams have been created. These are teams for that term-long project. That's a big component of this course. You can find the teams list on the Teams List tab on OWL, and everyone that requested a team should have gotten it. So if you look on the team list and you're not on the team you requested, that's probably an error. Just let me know and I can correct that. So if you have a problem with the team you're on, like you had a serious conflict with one of the team members before, you can still request until September 23rd to have a change in your team membership. This is only for really good reasons, like past conflict with a team member, not just because you want to change the team at this point. So right now, most of the teams just have a boring name like Team 1, Team 2, and so on. I am allowing teams to give themselves a more interesting name if you want. So if you want to change your team name, just send me an email and tell me what your team name should be changed to. Please do that by September 23rd. This doesn't have any bearing on anything, it's just for fun. So if you want, you can leave your team as just generic Team 1, Team 2, something like that. The next announcement is this week, weekly team meetings should start. Recall that one of the parts of this project is to have weekly meetings with your team, and during these weekly meetings, you have to keep minutes. So this isn't a transcript of everything that's said, it's not that detailed. Rather, it should be some high level things, like the time you met, who was in attendance, the location you met, what was discussed, what was decided, and what things are going to be worked on next, as well as maybe any obstacles that you're currently working on. So for full details on what should be in your team minutes, please see the project management component, which should now be posted on OWL. So a big thing you should be working on this week is your team contract. That's part of the project management component, and it's basically going to set your expectations for your other team members, when you're going to meet, and things like that. We'll go into more detail a little bit later on in this video. The other thing I should mention is that meetings do have to be face-to-face. So that could either be in person, or it could be online using something like Zoom, so long as the webcams are on. We do have collaborative rooms here at the university that you can book, such as MC220, MC239, and MC325. If you click on those links in the slides, or you just navigate to the Computer Science Department website, you can find them, and it should allow any computer science student to book these. So that might be a good place for your team meetings. So I should also mention that a private team forum topic has been created on OWL for each team. These are optional to use, but they might be a good way to start getting set up with your meeting times, arranging that first meeting, and so on. You're free to use them or not, or discuss things in another medium. Just remember that, at least for the team meetings, it does have to be face-to-face. And as it says here, only your team members should be able to see those posts, so they are private to your team. The next big announcement is some of the project component details are now available on OWL. The big one that you should be worrying about, because that deadline's coming up, is a requirements document. And that's going to be October 11th, and it's going to be the first big milestone for your team. The second component is going to be the project management component, and this is going to be based on sort of like how you're managing your project. This is going to include things like team minutes for your weekly meetings, team contracts, and how you're basically managing in Jira and some of the other software we're going to be using. And the last project component that's posted is peer review. So that's going to be an individual component where you sort of review your other team members in a professional way. It's very similar to what happens in real life in industry. So the project management and the peer review components aren't due till the end of the term. However, you should be working on them through the whole term. Make sure you're keeping notes, keeping things up to date, because you can't really go back in time and do weekly meetings at the end of the term. So make sure you do review and read all of those components fully right now. Don't wait to the deadline, because it will be too late to do things like team meetings. Another big announcement is TA consulting hours have started. So we have two TAs for this course, and they're going to hold 2-hour drop-in sessions in a lab in Middlesex College. So you're free to attend these, ask questions about the project, the course, any course material. And these labs do run Windows, so it is another space that you could work on your team project. And if you do it during the TA consulting times, then you'll have someone to sort of talk to about the project while you're working on it. So for details on when those are going to be held and the exact lab numbers, see the TA consulting tab on OWL. And that will have a full schedule of when the TAs will be there, their contact information, and things like that. So one of the other things I should mention is the team contract. I mentioned that a little bit before, but basically this team contract is going to have a few details that sort of set the expectations for your other team members. So this is important to get straightened out right away, and it's going to be an important document because this is sort of going to be how I judged your efforts. So if you say that everyone's working at least 10 hours a week or something like that on the project, then I'm going to, when I'm looking over the peer reviews, looking over the project at the end of the term, I'm going to see, does it look like someone put in 10 hours of work? So part of your mark is going to be based on fulfilling your team contract. So this team contract should have things like how your meetings will be held each week. They're going to be in person, online, using Zoom, the location of your meetings, if in person, the length and format of your meetings, who will take minutes, so you could assign one person to that, or you could have it change each meeting, and how your meetings will be scheduled. Are you going to have them all scheduled at a certain time every week for the whole term, or are they going to be more flexible? They just have to happen once a week. How you do it is up to you, but it should be specified in that team contract. Another thing's going to be work norms, how long team members are expected to work on the project each week, how team deadlines will be set, how the work will be reviewed by other team members. So maybe when you're finished a component, you might have someone else review it. And things like what happens if people have difference of opinions about a task or a way the project's going. Are you going to hold it to a vote? Are someone going to be in charge of certain components and get the final say? How that works is going to be up to you, but should be in your team contract. Another thing will be the division of work, and this should be at a high level, because we're not going to have a full understanding of who's going to be assigned what yet, but you should have some idea of how you're going to divide work at least. And this is something that you're going to have to revisit as you go on, so the team contract should sort of be seen as a living document that can be updated as you go on, as long as all members are agreeing to that. So another announcement is that I'm working on getting that software set up for you. So this is going to include Jira, Confluence, and Bitbucket, and you're going to need these for your project. So I'm working on that right now. I'm going to post an announcement with the instructions when that's available. But for now, if you want to get a head start on the requirements or documenting your team minutes, what you can do for now is use a word processor or something like that. And then once those things become available, you can then move like your team contract or your team minutes onto Confluence, for example. To give a quick summary of what these are, Jira is an issue tracker and project management system that has Kanban boards and things like that. Confluence is sort of like a corporate collaboration workspace and team wiki. And Bitbucket is a Git-based source code repository. We're also looking into getting you some software for creating wireframes and sort of mockups for GUIs, and I'll have that information available for you as well, hopefully all next week. And once that's all available, I will be going over how to use that software. Okay, so where we left off last week was discussing prescriptive process models. And these are models that have a very strict or rigid or orderly approach to software engineering. So activities and tasks occur sequentially within defined guidelines for progress. And we call these prescriptive as they prescribe a set of process elements and process flows. So this really rigid structure leads to a few questions. So the first one is, if prescriptive models strive for structure and order, are they appropriate for a software world that thrives on change? In that first week, we talked a lot about change and how it can impact software development. So the models we're going to be taking a look at are very strict and rigid. So that means they don't really handle change that well. So the one question that comes up are they going to be appropriate if that's the case? But then on the other side, if we reject these traditional process models and replace them with something less structured, like agile models that we'll be talking about later, do we make it impossible to achieve coordination and coherence with software work? So if we throw out structure and all this like heavy documentation, are we still going to be actually able to produce this software? Well, we know what we're doing, things like that. So there isn't any real easy answers to this, And the best method is, as I've mentioned before, is to adapt these processes for your needs. If you have a small project with a small team like just you, maybe some of these prescriptive process models will make sense if you don't have a large stakeholder. However, in other cases where things are rapidly changing, the industry's changing, the technology used are changing, maybe an agile approach will be better. So let's get into it. So the first process model, and probably the most famous one, is the waterfall process model. And this is called the waterfall model because you can kind of see that each activity flows into the next, falling downwards. So we go from communication to planning to modeling to construction and deployment. This is called the classic life cycle. But there's some problems with this. Maybe you can see it right away by just looking at it. And that is, there's not really any feedback flows between any of these activities going backwards. There's no way to sort of go back if you found an error. So you may have done the communication activity, found all the requirements you need, and then moved to planning, and then got to modeling. And then while you're modeling, you realize that maybe a requirement doesn't make sense, or something that you planned isn't quite going to work out. It's going to take a lot more time. There's no way to actually go back. The second big issue is stakeholder involvement is only at the communication phase and the deployment phase. That means that stakeholders are only going to really be involved at the beginning of the project and the end of the project. This can be a big problem because it's not always clear what the stakeholders actually want, what the requirements are. And by the time you get to deployment, maybe you made something that isn't really what they wanted. The upside is it's very ordered and very simple, so it's easy to understand. So, while it's usually considered an anti pattern almost, something that you shouldn't use, it can still make sense for individual projects, maybe where you're the only person working on it and you're the only real stakeholder, like a personal project. So, just to go over those pros and cons again, it's easy to understand and plan. It works for well understood small projects. Maybe if you're on a small two-person team making just a simple static web page, something like this would make sense. But even then, you'd probably want more feedback from the stakeholders. Analysts and testing are straightforward, but there are some cons, as we mentioned. Doesn't accommodate change well, testing occurs late in the process, and customer approval is at the end. So it means you could be in big trouble if you get to the end and they don't approve. You're going to have to restart the whole process. Another common process model we sometimes see is the V process model. This is a variant of the waterfall model, where we go from requirements modeling, architecture design, component design, code generation, and then we get after the code generation point, we usually have some kind of executable software, and we start going upwards. Now we're going to do testing and analysis on the software that we created to see if it really meets the requirements, if it passes our tests. So we do things like unit testing, that's where we're testing small individual components of the software, integration testing, how those components fit together, system testing, and then acceptance testing. Acceptance testing would be, does the customer accept what we've created? Does it meet their requirements? There is a big problem here. Perhaps you can see it. And that is this actually different than the waterfall model? I mean, it does a good job of showing how these different testing steps connect to each activity, but really it's just the waterfall model that's been broken in half and bended upwards at that last stage before deployment. So that means it really has all of the same issues as the waterfall method. So let's go over those pros and cons. So the pros, remains easy to understand and plan, just like the waterfall. It works for well understood small projects. The analysis and testing are straightforward, and it is at least a good way to verify or visualize how verification and validation actions are applied to earlier engineering work. The cons is there's no fundamental difference between the V model and the waterfall model. The waterfall model is just simply being split and folded up right between coding and deployment, and it doesn't accommodate change as well. Again, you're only talking to the stakeholders at the beginning and the end, so you're going to have a big problem if they don't accept it. And testing is only occurring at the end after we've made the software. In an ideal model, we should be testing all the way through. And like I said, customer approval is at the end. So the next model is the prototyping process model. So the prototyping model begins with communication, collecting initial requirements, and outlying areas where further definition is necessary. Prototyping iteration is planned, with quick models and designs created, focus on aspects of the software visible to users, and design work leads to a construction of a prototype. Prototype is deployed, evaluated by stakeholders, provide feedback to further refine requirements in design. So the idea here is that you're putting out quick prototypes and getting them back to the stakeholder right away so that they can take a look at it and see if this is what they want. We often find that during the communication phase, when we're gathering the requirements, what the customer or the client says that they want isn't really what they want. And they don't really understand what they want until they actually see it in front of them working. So, having a quick plan, quick modeling, and then construction of a prototype really quickly, and then getting it to the stakeholder means that they can see right away what it actually is looking like, that what they're requesting, and then they can make changes to it. So this would be an example of a process model with iterative flow. So each time we're going around this loop, we're making a new iteration of the software, a new prototype. The pros are it reduces impact of requirements changes. The customer is involved early and often. Each time we go around that cycle, we're getting the customer involved. And it tends to work well for small projects, and it reduces the likelihood of project rejection. Works well for small projects or projects that can be broken up into components, so your prototype can focus on a specific component or adding a specific requirement each time. For really large, complex projects, it can be a bit complex because you might need a lot of different components working before you can actually have a prototype that means anything to the stakeholder. The other issue is getting those stakeholders involved may cause delays. You're going to have to schedule meetings for them to show them software and things like that. So you might have time where you're just waiting on them to give feedback. The other issue is that there's sort of a temptation to ship the prototype. So when the customer sees the prototype, they're like, oh, yes, this is what I want. And even though you may only really have the GUI mocked up and coded, you don't really have any of the back end stuff working. And they'll consider it to be done. They don't really have an understanding of all the stuff in the back end that has to be completed. The other big issue is that you lose a lot of work if you have to throw away a prototype. Sometimes a prototype just isn't working out, and it can be hard to actually decide to throw it away. So this can go two ways. It can be bad if you throw it out because you lose all that work you've done and have to start over, but it can also be bad if you choose not to throw out a prototype that needs to be removed and refactored or something like that. It can also be hard to plan and manage. You don't really know when this is going to end, and you don't really know how that prototype's going to go necessarily. The next one is the spiral process model. This is another evolutionary approach, and it also uses sort of prototypes and iteration. So it couples the idea of that iterative nature of prototyping with the controlled and semantic aspects of the waterfall method. So we're trying to sort of get the best of both worlds here. We want that controlled and well understood method while still getting those frequent prototypes that we can get out to the stakeholders. It's also a very risk driven approach. Remember, risk is sort of like identifying, or risk management rather, is sort of identifying potential problems that could come up in the planning stages, development stages, any of the real stages, and trying to avoid them before they happen. And this model actually has risk management built in, where you're constantly considering what kind of risks are going to be coming up. So part of that risk-driven approach is that prototyping becomes risk reduction method. So you're building prototypes as you go along, so there's always some code there, and you can show this to the stakeholder as you go. So that means you're getting some feedback from them to make sure that you're building what they actually want. So it starts at start in this diagram near the center, and you spiral outwards. You start with communication, that's getting the requirements, do planning, estimating how long this is going to take, scheduling, risk analysis, what are the potential problems going to be. Move on to modeling, you do the analysis and the design of the software. That's like sort of making models like UML that we'll get into. And then we move into construction. We're actually making the code, doing the tests, and then we move into deployment. So that's where we actually give it to the customer, get their feedback. And this is at the point where a prototype is released. And then we sort of get further out in the spiral. And the reason why we're getting further out from the center is as we go out from the center, we get a more complete system. Prototype becomes more complex and it becomes more finished. So as we get further out from the center, we get a more finished project, hopefully, but there's also more and more risk. It's getting bigger, more time's put into it, and things like that. So the pros are there's lots of customer involvement. Development risks are managed because that's part of the phase every time we go around that spiral. It's suitable for large, complex projects, and it works well for extensible products, especially if you can break it up into smaller parts. Cons are risk analyst failure can doom the project. So if you don't properly find those potential problems, the project may be hard to manage because, again, we don't really have a clear ending point. We don't know if we're ever going to end. Is the customer ever going to accept it as a final thing? and it requires a pretty good development team that knows what they're doing and is familiar with the process. The next one is the Unified Process Model. And this is a use case driven, architecture centric, iterative, and incremental model. And it's closely aligned with the unified modeling language. That's something we're going to be getting into soon in the course, but it tries to make big use of those UML diagrams and models during the modeling stage, as well as other stages like even requirements gathering and planning. It consists of a number of phases that map to those generic framework activities that we've been talking about, and it does that iterative nature. So as we're going around that circle, we're making a prototype or some kind of release that can be evaluated by the stakeholder. Now we can see those generic framework activities here: communication, planning, modeling, construction, and deployment. But the unified process tries to have them overlap a bit or join them together into phases it calls inception, elaboration, construction, transition, and production. Inception encompasses customer communication and planning phases, capturing requirements as a set of use cases, and formulating an initial architecture for software outlying major subsystems. Elaboration refines and expands upon preliminary use cases and architecture from inception to create use case, analysis, design, implementation, and deployment models. Construction. Using these models, software is created that makes each use case operational for end users. As components are created, they're tested individually and integrated to the whole. So the next activity is transition, and this is where the constructed software is delivered to customers and feedback is collected, and software teams create the necessary supporting documentation. Recall that the unified process model is really big on the documentation, so it encourages things like user manuals, installation guides, and so on being created. And all this documentation results in usable software increments. So it's not so much as a prototype as it could be actual software that the customer can use. This makes this model really good for more of a maintenance type system where, like, for example, maybe you're working on OWL, you want to add new features to that learning management system. Following this process would be a good way because each time you're going around the loop, you might actually be producing something that's deployable and usable. And the last one is production. So outgoing use of software is monitored, support is provided, and defect reports and change requests are submitted to shape the next increment or update to the product. So let's talk a bit about the pros and cons. So big pro is we get a lot of quality documentation. That's a big emphasis of this model. We really care about the documentation. So that means we're going to be producing a lot of great things for the users: user manuals, installation guides, and very detailed modeling. The downside of that, however, is that documentation isn't really great if you're never going to use it or look at it again. So some of the agile methods that we're going to be looking at in a bit try to get away from this overuse of documentation and try to emphasize only using documentation that's needed. So the unified process model is big on documentation. So if that's not something you actually need, that might not be a pro. But if it is something you need, like if you're supporting a living system like OWL, that would be a plus. Another thing is we have continuous customer involvement. In the cycle, we're always producing these increments to the customer, so they're getting constant feedback about what they like about it, what they don't like about it. And that means it also accommodates requirements change as well, because you're in constant contact with the customer. So it works well for maintenance projects, as I mentioned. So things like living systems like OWL, or something that you're sort of adding increments to as you go. The cons are the use cases are not always precise, so they might not be super detailed. The overlapping phases, like inception, elaboration, and so on, can also cause some problems. If you're doing communication and planning at the same time, you have a problem if the requirements are changing as you're trying to plan it, or if you're trying to plan it as you're modeling, things could change and cause issues. Now, these have just been a few of the prescriptive process models. There are many, many more, and I'm sure people are coming up with more all the time. But all of these really high structured models tend to share the same problems, which is that they don't handle change well. They're still appropriate, though, for some cases, like well understood projects, or for very, very large teams, very large projects, or really high risk projects. So now we're going to move on to talking about some of the agile methods. So now we're going to move on to the next slide deck and talk about agility and process. Specifically, we're going to be taking a look at a few different agile process models. And as we talked about with those last slides, there are some issues with the prescriptive process models we covered. and all prescriptive process models in general. And those all stem from the real world being fluid. Requirements change, market conditions change rapidly, end users' needs evolved, and new competitive threats emerge. And the problem with these prescriptive models is that they tend to be too rigid and structured to deal with this change effectively. So, agile methods aim to reduce the cost of this change. When we're talking about cost, we usually mean time when we're talking about software development. We want to minimize the time impact of these changes. And we also want to add a human element that the traditional models are missing. Another thing agile methods really focus on are being lightweight. And by this, I mean lightweight in terms of documentation. We really only want documentation and modeling for things that we're actually going to use and people are going to look at again. Making piles and piles of the best documentation in the world is great, but it's not going to be helpful if that just goes in a filing cabinet and no one ever looks at it. So we want just a sufficient amount of documentation. So what is agility? Well, in terms of software, it's effective response to change that's both rapid and adaptive. It also means drawing the customer or the stakeholders onto the team, and that means frequent communication with them and making them part of the process. It also means organizing a team so that it's in control of the work performed. So the team should be empowered to make certain decisions about the software and what they're working on day to day, so long as it's fulfilling the overall goals and objectives of the project. It also means rapid incremental delivery of software, sort of like we saw with prototypes and the other models. And the goal here is to reduce that cost of change. So when we're talking about prescriptive models, we tend to see a curve that looks something like this when we're talking about the cost of change versus how long we are in the development process. So the further you are along in development, the higher that cost of change is going to be. The reason why is a lot of those prescriptive models, especially things like the water flow model, didn't really have a feedback mechanism to deal with the change. They only sort of dealt with the stakeholders at the beginning, during the communication, and at the end during the deployment. So if the change happens somewhere in the process, there's going to be a really big cost to going back and doing it again. So with Agile, the goal or the idealized curve would be something like this, where at the start it's a little bit cheaper to have change, but then otherwise it sort of stabilizes out of a flat line with a relatively low cost. However, in real life with Agile methods, we see something that looks a little bit more like this, where we still get a big benefit over the prescriptive models. However, we still tend to suffer from cost of change going up closer to the end of the project. And you can kind of see why that would be if you just think about it a bit. Even if you have the best Agile method, you're still, if you're at the very end of the project and the customer comes to you wanting a massive change, there's going to be a cost to that. It means you're going to have to restart cycles, you're going to have to do a new increment, and if that change is big enough, it means that you're going to have to throw out old prototypes. So no method is going to be perfect, but we tend to see Agile methods handling change better than prescriptive ones. So the Agile process is built on three key assumptions. And those are it's difficult to predict which software requirements will change. So we may have a big list of software requirements that we gathered for the communication activity. And while we can make some educated guesses, it's hard to tell what's in the mind of the stakeholders, what requirements might change because market changes, their needs changes, or what might change because they might not be technically feasible. The second key assumption is that some activities should be done in tandem or at the same time. The reason for that is that way we get better feedback and coordination between those activities. The third key assumption is that analysts, design, construction, and testing are not predictable. For example, maybe you just planned in your designs to use a certain API or library, but when you started construction, that actually didn't fulfill your needs. It didn't get you what you wanted. So you have to switch to a different one, and that's going to cause redesign costs and things like that. Another example would be maybe during design you thought something would be trivial to solve, but when you actually got down and tried to build it, it didn't turn out to be that easy. So with all these assumptions, they all are dealing with uncertainty. Uncertainty due to change, uncertainty due to our plans being incorrect, or uncertainty due to errors earlier on in the process. So we need adaptability to deal with that uncertainty, and that's what Agile's trying to be all about. So as I alluded to, the answer to this uncertainty is process adaptability. So our processes we use must adapt incrementally based on customer feedback. So we can't just have everything changing all at once completely. That would mean nothing would ever get done. Instead, we want to deal with change incrementally at certain points in the process. Another big part of the agile process is the rapid development of software increments as executable prototypes, usually within 2 to 6 week periods. And these prototypes are important because they act as a catalyst for customer feedback. Customers don't always know what they want in the requirements gathering phase, and when they actually have something in front of them, it helps them understand what their real requirements are, what they actually like or don't like about the software. So, getting that feedback often and frequently as you go can help to deal with changes. You don't wait till the very end and show it to the customer, and then they want a big change and you have to go back. Instead, you're constantly showing them the software as you're developing it so they can give feedback and guide the process. So these agile processes we're going to be discussing tend to work best for small teams. So if you're like a big company like Microsoft working on a massive monolithic thing like an operating system like Windows, they might not be the best method unless you can really compartmentalize or break the problems down into specific things that smaller teams can work on. And these teams must have some certain key traits among the people to be effective in an agile environment. There's competence. You need experienced developers that know what they're doing. They need to have a common focus. They have to have collaboration, decision making abilities, fuzzy problem solving abilities, mutual trust and respect. That's actually one that you might not think of, but it is a really big one. You have to really be able to trust that the other people on your team are getting done what they say they're going to be getting done. And this is going to be something that you're going to come across in your project, I'm sure. And they also have to be very self organizing. Agile teams try to give a lot of the power to the team itself, the development team, rather than strictly managed by a project manager. So they do have to have the ability to plan out themselves what they're going to be doing, what things they're working on, because those prototypes are going to be developed rapidly, so everyone has to be on the ball. And they're going to need to have discipline to stay committed to those schedules, those deadlines, and those milestones. There are costs, however, to agile processes. It's not all sunshine and rainbows. And usually this is in terms of predictability and manageability of the project. So these agile methods that we're going to be looking at times can seem rather chaotic and uncontrolled. This is particularly true to people that are sort of set in the old ways, in the traditional models, or management that's very hands-on and likes to have fine control of their development teams. So it can be a hard sell if you're trying to introduce this to an organization or team members that aren't used to an agile process. And like those traits we mentioned before, if the people on the team don't have those right traits, it is very easy to have the whole agile method collapse back to just no process at all, no control over what anyone's doing, and no sort of coordination. So it does require a team that has discipline and leadership that is familiar with the agile process and has the ability of keeping everyone on task and on track. So there are a few key agility principles that we'll cover here, and these come from the Agile Alliance, and I have their URL up there on the slide. So the Agile Alliance is a global nonprofit membership organization, and that was founded on the Manifesto for Agile Software Development that our textbook talks a little bit more about. And their goal is to support people and organizations to explore, apply, and expand Agile values, principles, and practices. They do sort of a lot of workshops and professional development related to Agile methods. So here's some of the principles that they profess. So the first one is our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So that's getting those prototypes out there early and in a continuous way, so there's continuous feedback from them. Number two is welcome changing requirements, even late in development. Agile processes harness change for the customer's competitive advantage. So we haven't talked much about competitive advantage. It's more of a business subject, but that's sort of like the business's ability to have some advantage over its rivals. If you're able to change your software that you're using at a drop of a hat, that would give you a significant competitive advantage. So a software team implementing processes that are able to harness change well, deal with change well, can give that organization a competitive advantage over its business rivals. Number three is deliver working software frequently, from a couple of weeks to a couple of months, with a preference to shorter timescales. So once again, like I was saying, we're trying to get those prototypes out there frequently so the customer has say in those increments as the process goes along. Number four is business people and developers must work together daily throughout the project. So we don't want just developers involved in the process. We also want stakeholders. So those would be the business people in this case. Number five, we want to build projects around motivated individuals and give them the environment and the support they need and trust them to get the job done. So the big thing here is trust them to get the job done. So we don't want management that micromanages. Instead, we want developers to have the ability to identify the tasks that they need to work on and get that done without having a big overhead, like things like too long meetings, things like not being able to work on the things they think are important. You have to trust your development team to know what they're doing and to be able to get that work done on time. Number six is the most efficient and effective method of conveying information to and within a development team is face to face communication or conversation. And this is why I'm really pushing for face to face meetings with your group. And in the past, this used to mean actual in person meetings, but in partly due to the pandemic, this started to expand out more to face interactions that could be over Zoom, for example. And a big reason for this is you've probably experienced this before where you're talking to someone through something like email, send a message, then you have to wait a few hours for the response, then something they didn't understand or not, then you have to wait, send an email, wait another few hours. It's that in a 15-minute conversation face to face, you could probably convey, understand, and explain more information than you could be through like a day's worth of emails. So we want fast, effective communication. And a good way to facilitate that is with face to face conversations. Number seven is working software as a primary measure of progress. So instead of measuring progress by certain milestones or certain documents being produced, we want to measure our progress on the project by the actual software. Is it passing the tests? Is the customer accepting prototypes? And things like that. So we wouldn't want to measure progress like things like lines of code or something silly like that or other metrics. The actual metric for progress should be software fulfilling requirements and tasks. So number eight, agile processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. So we want a process that's actually maintainable. We don't want to like put a crazy amount of work on our developers and think that, oh, we can do that next time when we're really burning them out. We want a process that we can repeat over and over again with every project for hopefully indefinitely and still get continuously good results. Principle number nine is continuous attention to technical excellence and good design enhances agility. We want to focus on producing a high quality product. Number 10 is simplicity. The art of maximizing the amount of work not done is essential. And I talked about this a little bit. We don't want to be producing documentation and models and things that we're not actually using. We want just sufficient to accomplish our requirements. Number 11, the best architecture, requirements, and designs emerge from self organized teams. And number 12, at regular intervals, the team reflects on how to become more effective and tunes and adjusts its behavior accordingly. And that's the whole idea behind continuous improvement. After we've gone through a cycle or we've completed a project, we want to take time to look back at it, see what we did well, what we did wrong, and try to improve it next time. Remember, this isn't just like a strict prescription of methods to complete a software project. We have to adapt it to our own team, our own organization, and our own objectives. So we want to always be improving how we're adapting that process. So enough of that, let's now take a look at some specific Agile methods. And the first one is Scrum. So if you're familiar with rugby, this name comes from rugby. It's when a group of players form around the ball and teammates work together to move the ball downfield. So in terms of this Agile process, this is specifically referring to certain meetings that are going to occur in the process that we'll get to in a second. So in Scrum, the core framework activities are called requirements, analysis, design, evolution, and delivery. And these pretty much fit in with those generic ones that we've seen before. Requirements would be communication, analysis would be planning, design would be modeling, evolution would be actually The creation and delivery would be deployment. The difference of naming comes, there's a little bit of a different of focus. So the communication, the pure focus is on requirements gathering, on, for example, construction. We could call it evolution because we're trying to evolve a prototype to get more complex and more complete as we go on. Tasks in each framework activity take place in a short time box called a sprint, normally 2 to 4 weeks in length. And the Scrum team consists of a few specific members. The first one is the product owner. So this is usually a key stakeholder, and it's someone that's responsible for maximizing the value of the product resulting from the work of development team. And their key responsibility is going to be managing something called the product backlog that we'll get to shortly. So really, this is the stakeholders representative that's actually part of the team, and that helps us get that continuous feedback. The next is the Scrum Master. So this is a facilitator to all members of the Scrum team. They run the daily Scrum meetings, remove objectives identified as obstacles by team members, and they deal directly with the product owner. They also sort of act as sort of almost a shield from higher management to sort of be an intermediary between them and the development team. So the developers are free to deal with what they do, coding and planning and design. Now, organizations tend to deal with Scrum Master a little bit differently. In some cases, it's a permanent job where that person's sole job at that company is being the Scrum Master for one or more teams. In other organizations, it's just a developer that has a few additional responsibilities. And in some, it switches project to project. Next is the development team. This is usually 3 to 6 people. Remember, these agile methods work best for small teams. So they create software increments and decide when increment is done and when to present it to the product owner. So one thing you might be wondering is if this is only for about 3 to 6 developers, how could it ever be used for something big, like modern video games, for example, probably have teams in the hundreds? Well, the key thing is breaking your problem, or something like a video game, into many small compartmentalized components. And that way you can have specific teams for each one. You might have a team, for example, in the case of a video game, dedicated to graphics, one dedicated to the game engine, one dedicated to like designing the dialogue and characters. You might have some teams solely dedicated to just developing tools that the other developers will use to create that game. Now, there's a few artifacts that the Scrum method emphasizes or creates. The first one is the product backlog, which is a prioritized list of product requirements. And these items can be added to the backlog at any time, so long as they have the approval of the product owner and the development team. This is in one way that Scrum handles change. So at any time, changes to the requirements can be added to the product backlog. And it's the responsibility of the product owner to order the items in the product backlog based on the value or the importance of them to the organization or to the stakeholders they represent. The next artifact is the sprint backlog, and this is a subset of the product backlog. That means it's going to contain some of the items from the product backlog, but not all of them. And what this sprint backlog represents is the set of items that are going to be completed during the current sprint. A sprint is a set period of time, like we said, about 2 weeks, where you're actually working on constructing the prototype. So that means the sprint backlog is basically the requirements that you want to get implemented during the sprint. An important rule is that items cannot be added after the sprint starts, unless the sprint is completely canceled and restarted. Remember that we said agile methods want to deal with change incrementally. Can't be complete chaos where the product owner is just throwing new things in the backlog while you're actually working on it. That would make sense. So we have sort of like a frozen backlog for the duration of the sprint. Product owner could still add things to the overall backlog, but at least what you're working on for that 2 week, 4 week block is going to be static and unchanging. And the last artifact is the code increment. So that's the union of all the product backlog items completed in previous sprints and all sprint backlog items to be completed in the current sprint. So that's basically your current prototype to date, what you've implemented from the backlogs. So Scrum really emphasizes a lot of face-to-face meetings, though it does try to make the more frequent ones short as possible. The first one is the backlog refinement meeting. This is where developers are working with the product owner and the stakeholders to create that initial product backlog. And then everything in that backlog is rated by importance of the product owner's business needs. The next meeting is the sprint planning meeting. So this one is held prior to starting a sprint. And the idea here is that the product owner is going to give the team goals for the next increment, and the Scrum Master and the development team select items from the product backlog to add to the sprint backlog. Remember, that's what they're going to be working on in that sprint, and it's frozen once that sprint starts, so you can't make any changes to that backlog until the sprint is done or canceled. The next one is going to be the daily Scrum meeting. So this is going to be one that happens every day, whereas like the sprint planning meeting only happens once a sprint, so maybe every 2 weeks to 4 weeks. Well, the daily meeting every day. And because it is a daily meeting, it is tried to limit to 15 minutes maximum. We don't want to use up all the developer time in meetings. And the purpose of this meeting is to ask 3 questions to each member of the development team. The first one is, what have you done since the last meeting? And then the next one is, what obstacles are you encountering? And the last is, what do you plan to accomplish next meeting? So this does a few things. It keeps the developers accountable for what they're doing, keeps everyone coordinated to know what each other are working on. You don't want people redoing the same efforts. And it also lets the Scrum Master understand what obstacles are in the way that they need to work on. Maybe they need a certain tool, maybe they need a change to their development environment, maybe they even need something like a new, more powerful server. And then that Scrum Master can work on getting that from higher up in the organization, while the developers work on what they're good at coding. So the Scrum Master tries to clear those obstacles by the next meeting, and developers try to finish what they plan to accomplish by next meeting by the next meeting. But it's important to point out these are not problem-solving meetings. They're not getting together and discussing how they're going to solve something or what problems they're having with solving it and working together. Instead, those would occur offline and only involve the developers actually involved in that problem. There's 2 more meetings. One is the sprint review meeting, and that occurs at the end of a sprint. So the prototype they make, or the demos, are delivered to the stakeholders for approval and rejection. So during that meeting, the product owner and possibly some other stakeholders are given the prototype and showed the demo, and they have to provide feedback for the next sprint. And during this meeting, new features are commonly added or removed from the product backlog based on the feedback from the stakeholders. This meeting would then lead into a new sprint planning meeting, and then the sprint process would start again. There's also a sprint retrospective meeting. So this is another meeting that occurs after a sprint is complete, but it usually only involves the team, so the Scrum Master and the development team. And the purpose of this is to sort of decide how we can improve the process. Remember, one of the Agile principles was that we wanted to have methods for continuous improvement. So they discuss a few things like what went well, what could be improved, and what the team will commit to improving in the next sprint. This meeting's run by the Scrum Master, and they would take that feedback and try to use it to develop the process better for the next sprint. So not only are we developing software, and hopefully that software is getting better, we're also developing the processes and procedures that the team and organization uses as we're going. So hopefully we're making good software, and we're also making our whole process for making that software better as we go. And this is sort of a visualization of Scrum. So on the left here, you see we have the product backlog that's prioritized by the customer for the product owner. And then we take certain items from that product backlog and we put them into the sprint backlog. Once we start a sprint, the team starts working on those features. And every 24 hours, every day, there's a 15-minute daily Scrum meeting. And after the end of the sprint, we then have those product demos, and that new functionality is demonstrated. It says 30 days here, but again, it can range from 2 weeks to up to 6 weeks. From the examples I've seen in real life, a lot of teams now seem to be focusing on 2-week sprints, but again, it's a process that has to be adapted to your individual needs. So overall, the pros are product owner set priorities by organizing that backlog. The team makes its own decision making Once that sprint started, everything's locked in and it's up to the team to decide how they're going to implement it and how they're going to accomplish those features. The documentation is really lightweight. We only want to make the documentation that's necessary, and it supports frequent updating. That product owner can put new things on the backlog whenever they want. Product backlog, that is. And the cons are it's difficult to control the costs of change, or, for example, the stakeholder or the product owner could keep sending it back for a new sprint. That means going around and around, taking more time. And it may not be suitable for large teams. We talked about how you'd have to break a big problem up. Imagine if you had a team of 200 doing a daily meeting like that where you asked every single person those questions would probably take the whole day, not 15 minutes. So we really do need to keep it limited to a team that's small enough that could handle things like those meetings. It also requires team members that are very familiar with the process and understand the benefits and the reasons behind why they're doing this. So the next method we're going to look at is called extreme programming, or XP. And extreme programming encompasses a set of rules and practices that occur with the context of 4 framework activities. So this one focuses on 4 activities rather than the 5 generic ones we saw before. Those are planning, design, coding, and testing. So the main focus of the planning activity is the creation of user stories. So user stories are a type of documentation that describes the required output, features, and functionality for software to be built. User stories are written by the customer, and for example, they could be placed on index cards or in some sort of online electronic system. And for each one, a value is assigned and estimates for how long that new story would take to implement in the software. They also commonly have acceptance criteria attached. We'll get into that in a sec. So teams take each story and assess the story and assign a cost. The cost here isn't in dollars, rather it's in development time. So number of weeks, number of days to actually implement that story. Stories are grouped together to form a deliverable increment. So this is sort of like the sprint backlog in Scrum. Instead, these are like a group that they're going to implement during the next construction phase. So then the delivery date for the increment is decided. At first, that's usually just based on the cost from all the user stories that are going to be delivered in that increment. But then after the first increment is completed, a project velocity can be calculated, which sort of makes that more and more accurate estimate each time. So we get a better idea of the delivery date each increment of the software. So I did mention user stories there. This is an example template for what a user story might look like. So user story is usually formed in the form of as a blank, where blank is a type of user or actor in the system. For example, it might be just as a user or as an administrator. If it was something like a learning management system, it might be as a professor or as a student or as like a grade administrator. I want to perform some specific task. And you also need to have some reason or goal associated with why you want to perform that task. So to keep on going with the learning management system example, might be as a student, I want to access my assignment grades so that I can assess my current standing in the course. So acceptance criteria, which is often attached to user stories, is what actions should actually be carried out by the system and what outcomes should be observable in the system. How does the state of the system change if this user story is performed? And they take the form of given that blank, when blank, then blank. So it would be given that some context happens, when some action is carried out, then some observable change in the system should happen. So let's take a look at an example. So in this example use story, someone forgot their password and they want to reset their password link. So the user story might be, as a user, I want to be able to recover my password to my account so that I can access my account in case I forgot my password. And user stories should be relatively simple like this. You can have a lot of them, but you want them to be very obvious of what the intent is. And the acceptance criteria in this case might be given that the user navigates to the login page, when the user selects the forgot password option and inputs an email, then the system sends a password reset link to the entered email if it is valid. So you also could have multiple acceptance criteria attached to a user story, So you might also want one that says what happens when they actually click the link on that email. You also notice that I have a title for this, a priority, and an estimate. So the priority and estimate in this case are just made up because it's just an example. But what would happen is the stakeholder would be assigning priorities to each of these use stories based on how much value or how badly they need them in the system. And the developers would be putting in that estimate for how many weeks they think it would take to actually implement that user story. And that brings us to our group work for the week. Or in this case, since we're doing this online, it would be individual work. So what I want you to do is write a user story that describes the favorites, or also called the bookmarks feature, available in most web browsers. While you use sort of the template to the right. You don't have to worry so much about the title, priority, or the estimate, but you should have the user story and the acceptance criteria. It should be in the form of as a blank, I want to blank so that I can blank for the user story, and for the acceptance criteria, it should be given that blank, when blank, then blank. And remember, you can have more than one acceptance criteria. The way I'd like you to submit this is on our OWL course site. There should be now a form called Week 2 Group Work. And I'd like you to basically type out your user story and your acceptance criteria and post it in the form. The one catch here is that you won't be able to view anyone else's posts on that form until you post your own. Once you posted your own, you're free to take a look at the other people's stories, and if you really want to, you could provide some constructive feedback, although that isn't required. So there won't be a group code, rather I'll just track it through the form post you made. And to get credit for this, you do need to complete that form post by Monday next week. I will post a solution to this activity next week, but one of the advantages of doing it this way online with the OWL forms is that after you post, you'll be able to see everyone else's solution. So you'll have some good idea of what the correct answer is after that. So continuing on with extreme programming, the next activity is design. And this generally follows the KISS principle. That's keep it simple, stupid. And it encourages the use of CRC cards, or class responsibility collaborator cards. And this is a mechanism to think about software in an object-oriented context. So CRC cards identify and organize object-oriented classes that are relevant to current software increments. And we'll talk about this more when we get into requirements and chapter 8 of the textbook. So the CRC cards are the only work product from the design activity, no other documentation. But one thing that is encouraged is to think about design both before and after coding commences. What they mean by this is something called refactoring is encouraged. So refactoring is the modifying or optimizing of a code in a way that does not change any of the external behavior. So you may have done this yourself when you're working on an assignment or a personal project. You write it and it's kind of getting bloated and all over the place, and you just want to rewrite that code to be a little more elegant and neat, maybe remove some redundancy, make it a bit cleaner. So that would be refactoring the code. You didn't actually change what the code does, you just made the code quality higher and the design better. So this is what it means by design occurring both before and after coding. The next activity is coding. And the big emphasis here is that unit tests are created before the code. Unit tests, again, are tests that just focus on certain components of the code. Maybe they just test one function, put in certain inputs, get certain outputs, and check that they make sense. And this is usually done through automated means. That means using tools to automatically run this test, as opposed to having a human there, putting in some input, and then manually checking if it's correct. And when we develop software in this way, where we're writing the tests first, this is something called test-driven development, or TDD. The other thing it encourages during the coding phase is pair programming. This is when two people are working together at a workstation for real-time problem solving and quality assurance. So there's a number of different ways pair programming can be implemented, different styles different organizations can take, and it usually depends on how the team has adopted it to their own processes. So in an unstructured style, there's two people at a computer, and they sort of switch back and forth between who's doing the coding and who's doing sort of the quality assurance, just based on the flow of the team, based on how it's going. So there's not one set person doing one thing. In driver navigator approach to pair programming, one developer sets the architecture or strategic direction, and the other actually implements the decisions as code. The person who sets those directions is also doing sort of quality assurance, making sure that what they're doing makes sense. And then the last one is ping pong. So in ping pong pair programming, it shifts rapidly back and forth between the two developers, like a game of ping pong, where the software is the ball. That's commonly two people sitting close together working on similar or the same problem, but with two computers instead of just one. One thing I will note about pair programming styles is that they can be a little bit stressful on programmers. Having someone sitting there the whole time looking over your shoulder, sort of evaluating what you're doing, does kind of lead to burnout pretty fast. So, when implementing paired programming, it's important to also make sure that it's sustainable. That is one of the agile principles. So, some teams sometimes only do pair programming for certain parts of the day or rotate who's doing it just to give a little bit of a break from it because it is a bit harder than programming on your own in some regards. So, the last activity in the XP framework is testing. So, all unit tests are executed daily, preferably in an automated fashion. Acceptance tests are defined by the customer. These typically come from the user stories and those acceptance criteria attached to them, and they're executed to access customer visible functionality. So, acceptance tests, also known as customer tests and functional tests, validate the customer's view of the application. They're distinct from unit tests, which validate the programmer's view of the software internals. So here we can see a bit of a visual representation of this process, and you'll notice that there is refactoring on that code. So we have sort of a feedback loop there that just incorporates design of refactoring in the actual coding process. So there's some pros and cons to this method. The pros are it emphasizes customer involvement, establishes rational plans and schedules, and high developer commitment to the project. It also reduces the likelihood of product rejection. The cons are just like with other prototype processes, there's that temptation to ship a prototype. And it requires frequent meetings about increasing costs, allows for excessive changes, and depends on a highly skilled team of members. The next agile methodology we're going to take a look at is the Kanban framework. So, this is a lean methodology for improving any process or workflow. It doesn't necessarily have to deal with software. In fact, it was originally developed in Japan for just in time manufacturing. And it has a focus on change management and service delivery. So, Kanban board shows all of the project's tasks, their current statuses, and helps track their progression over time. And it tries to limit the amount of work in progress at any given time. So, in terms of software, developers are only focusing on certain tasks rather than a large set of them. So, a Kanban board is a visual representation of the tasks that need to be completed. The squares here each represent a task, and generally they move from left to right in the board as they're completed. So, they might start off on the left in the backlog, and then once they're selected for work, maybe in the next sprint, they're moved to selected, and when they're in the analysis phase, they're put in the analysis box. Then when they move to development, they're put in the development box, and then to testing when they're in the testing phase, and then move to done when they're done. So the idea here is to have most of your squares in backlog and done, and only have a few moving between these phases while you're working on them. So here we see a little bit more of a simplified version of Kanban. It is up to teams to adapt this, as always, so they might have different categories. So in this variant, the backlog is tasks waiting to be selected for development. To do would be tasks selected for development that are waiting to be worked on. And in progress are tasks that are currently assigned and are being worked on. Done are tasks that have been completed. And like I said, each organization has its own needs and goals, so they are going to have their own sort of categories and columns on this board. So one of the things you're going to be doing for your team project is going to be using a Kanban board on Jira. So it's going to be up to you to sort of define how your board's going to work for your team. So Kanban also recommends daily meetings called Walking the Board. In these meetings, teams identify any items missing from the board that are actively being worked on, and teams try to advance any items they can from where they currently are to the done column. The goal is to advance high value or high risk items first to the done column, as this lowers the overall risk of the project. An important thing here is this Kanban framework and these Kanban boards can be easily combined or used with any other agile development practices. So, for example, you could use this with Scrum or Extreme Programming. Any sort of agile methodology will probably be compatible with Kanban framework. And like I said, this isn't limited to software. So this is even something you could use in your own personal life if you're working on some big personal project, maybe an undergrad thesis or something like that. You could do the same thing to keep track of your progress and keep everything on track. So there's a few pros and cons here. It lowers budget and time requirements, allows early product delivery, process policies are written down, and continuous process improvement. The cons are teams' collaboration skills determine success, poor business analysts can doom the project, and flexibility can cause developers to lose focus. The last agile method we're going to talk about are DevOps, which comes from the word development operations. And it's sort of the combination of software development, the dev part, and IT operations, or the ops parts. And it attempts to apply agile and lean development principles across the entire software supply chain. So DevOps involves several stages that loop continuously. The first is continuous development. These are deliverables that are broken down and then developed in multiple sprints. Continuous testing, automated testing tools used prior to integration. Those would be things like the unit tests, accessibility tests that can be automated. Continuous integration, that's a big part of DevOps, is being able to add this new code that we've developed into existing running code. That makes it really good for systems that are alive or being maintained. Continuous deployment, which is integrated code is deployed to the production environment. So this is after you've added it to the existing code, you're actually putting it out in your environment. So for example, this was Owl, it would be adding a new feature, functionality to Owl, making sure that integrated correctly, and then launching it on the servers, making it live for everyone. And continuous monitoring, where the team's operations staff members proactively monitor software performance in the production environment to make sure everything's going correctly and to know any bugs or defects that they notice. So DevOps is really focused around those sort of kind of systems that where you can have continuous deployment and updating. So if there are things like Web 2.0 sites, things like OWL, learning management systems, things that usually have like this continuous high maintenance to them. And a visual representation of it is here. So you're going from planning, coding, building, testing, and then reintegrating into the existing code, deploy, operate, monitor, and then go back to planning to plan new features to add in the next sprints. So there's pros and cons to this, like with everything. Pros are reduced time to code development. Team has developers and operation staff, and that's one of the big differences between this and the other methods we've seen, which is that the other methods tend to just have developers and stakeholders rather than things like IT operation staff. Team has end-to-end project ownership and proactive monitoring of deployed products. So we're constantly monitoring what we've actually deployed, helps us to find issues, defects, bugs sooner. It's not like we're sending it away necessarily and just waiting for a user to eventually report it to us. So the cons are there's pressure to work on both old and new code, heavy reliance on automated tools to be effective, and deployment may affect the production environment. That's a big one. You push the new code and there's something wrong with it, then the system's going to go down for everyone. And it requires an expert development team, which is a common thing we see with most of these agile methods. So now what I'd like to do is just a little activity. I have a AHA Slides quiz that everyone should be able to do online, even if it's not synchronously. This is just for fun. There's no duck to be won or anything like that since we're doing it online this week. This isn't part of the group work or participation either. Again, just for fun. But if you want to try out this quiz, go to ahaslides.com and use the code CW7HZ. Or you could type in this full URL, or if you want to do it on a phone, you can scan the QR code on the screen. This will take you to AHA Slides, and it'll be just a quick quiz on some of the process models that we've covered, both the prescriptive ones and the agile ones. Great way to study and just reinforce your learning from these last two slide decks. So now we're going to move on to the recommended process model. at least the one that's recommended by our textbook authors. Now moving on to our last slide deck. And in this slide deck, we're going to talk about a recommended process model. So this is sort of an adaptation of the Agile and Spiral model recommended by your textbook authors. But within these slides, we're also going to talk a little bit about best practices and some principles for certain activities in the software process. So as we've talked about, every serious software project needs some sort of generic software process to follow or build on. But every project's a little bit different, and every team's a little bit different. Every organization has its own goals and objectives and ways of doing things. So no single software process or software engineering framework is going to be appropriate for every single software product or every single team. So any software process is going to have to be adapted to the needs of the developers and stakeholders and tailored to fit the current project and its team members and the user's needs. So what we're really going to be getting into in these slides and chapter 4 of your textbook is how one of these software processes can be adopted to meet the needs of a team. In this case, the textbook authors are taking the spiral, that's that prescriptive method, and they're going to be adding in some ideas from the agile methodology to sort of get the best of both worlds. And this is the recommended process that at least the textbook recommends. It's also based on some principles from a paper entitled Review of Myths on Original Development Model. I'll leave how to pronounce that author's name as an exercise to the reader. So now let's take a look at some of those principles. These are all principles for organizing software projects at a high level. The first principle is it's risky to use a linear process model without ample feedback. One of the most famous examples of a linear process model, which we've already talked about a little bit, is the waterfall model. And in that case, a lot of the risk comes from the inability to change and the risk from not involving the stakeholders enough. We only involve them in the communication and the deployment phase. So that means we could go the whole project without seeing them since the start until we get to the end, which is a big problem if some of the requirements changed. Second principle is that it's never possible nor desirable to plan big upfront requirements gathering. The reason why it's not desirable is you're going to put all that time into requirements gathering up front, all that cost associated with it, and they'll likely change later on. And this ties into point number 3. Upfront requirements gathering may not reduce costs or even prevent time slippage. And that, again, is due to change. Number 4 is appropriate project management is integral to software development. Number 5 is documents should evolve with the software and should not delay the start of construction. So again, that's getting into the idea that we're sort of going in cycles, working on the planning, the modeling, construction, and then back to them. So there should be some way to feedback or sort of go back and update the documents so that they evolve with the software. Number 6 is involve stakeholders early and frequently in the development process. That feedback from stakeholders is key so that we can manage change effectively. Testers need to become involved in the process prior to software construction. And the last point, number 7, is testers need to become involved in the process prior to software construction. So ideally, we want test-driven development, which means that we even create the tests before the code's even written. But we also want to have testing throughout the whole process, not just at the end, which we kind of see in the V model and the waterfall model. So the recommended process model, like I said, is going to be a hybrid of the Agile and the Spiral model. So the idea is to add Agile into every cycle of the Spiral model to sort of break it away from that prescriptive side of things. So what we see on screen right now is a version of the Spiral model that's sort of adapted for prototype development. Still not an Agile version, but it's one that's more focused on prototypes. And I'll just review how the Spiral model works. So we start off in the center of the spiral in the determine objectives phase. This would be sort of things like requirements gathering. You then continue on through identifying risks, that'd be any potential problems, and plan out solutions for them. Next, you plan out the next iteration of the prototype or the software you're going to create. Right now, we're just starting out, so this would be the first iteration. Then you do the construction, the development, and the testing, and you produce that prototype. And then you present it back to the stakeholders, get their feedback, and you have to determine the objectives, the requirements, how they've changed since then, and what they like about the prototype, what they don't like about the prototype, as we're going to use that to continue on with the process. So again, we start by identifying risks. What are the potential problems? Does it make sense to keep going on? We plan the next iteration. What are we going to add to the prototype? We construct the next prototype. And then we get the feedback again from the stakeholders. And it keeps going on and on like this, with the prototype getting more complete, more complex as we go on and outwards from the spiral. So again, just to review a little bit, some characteristics of an agile methodology versus an evolutionary model. Remember that spiral is an evolutionary prescriptive model. So for agile, it's not suitable for large, high-risk, or mission-critical projects. It's also, agile tends to be better for small teams. Number two, minimal rules and minimal documentation. Agile is a lightweight methodology, means we only want documentation when it's actually going to be used, when it's necessary. Number three, we want continuous involvement of testers for easy to accommodate project changes. That's the whole driver behind Agile. Number five, depends heavily on stakeholder interaction. Six, easy to manage. We want lightweight management. Usually teams are self-organizing, self-managing. Seven, early delivery of partial solution. Those are those prototypes. Number eight, informal risk management. That one's not necessarily a great thing if we're worried about risk. And nine, built-in continuous process improvement. So we have that process for improving. For example, in Scrum, we have that sprint review where we look back and see how the process could be improved. Now, when we're talking about the spiral evolutionary model, it's not suitable for small, low-risk projects, but it does do well for large, more high-risk projects. So we have the risk management built in, and it's designed for sort of bigger teams. Number two, several steps required along with documentation done up front. Sort of different than Agile, where the documentation is lightweight. Three, early involvement of testers. Four, hard to accommodate project changes until the prototype is complete. And number five, continuous stakeholder involvement in planning and risk assessment. Number six, requires formal project management and coordination. Number seven, product and not always obvious. We don't know when we're actually done in that spiral, but it does have good risk management. And again, it has process improvement handled at end of project. So what the textbook's trying to do is sort of combine these two to get the best of both worlds. So we want a method that's going to work for both the small and large projects, still focusing on a small team because it'll be agile. And we want to get the earlier development, lighter documentation, and sort of get rid of all the cons of both. So here we see on the screen the agile spiral model. This is that adapted spiral model that the textbook recommends. Looks a little bit complicated here, but you can sort of see the spiral in the flow, where there's a loop that keeps going. And we'll be going through each one of these points just to make everything. So the first stage after the project conception is the requirements engineering or requirements definition activity, highlighted here. So in requirements definition, there's a few key things. Number one, we have to encourage active stakeholder participation by matching their availability and valuing their input. Number two, we use simple models, for example, post-it notes, fast sketches, user stories, to reduce barriers to participation. And this is sort of the fault of some other models, sort of like the unified model, is that if we make really complex documentation in regards to requirements, it might be great for the dev team or people that are familiar with the development process, but it's going to be hard for your stakeholders to understand and be able to process that. So we really want to reduce those barriers to participation. One thing that you should have done by now is try writing a user story, and you can see how simple that is with just filling in those blanks. That makes it really accessible to any kind of stakeholder. And number three sort of ties into this, which is take time to explain your requirements representation techniques before using them. Everyone on your team should understand what they mean and what they represent, as well as your stakeholders. After all, the stakeholders are the one that's going to be evaluating your output at the end, so they should have a good understanding of at least what the requirements are. Number four, is adopt stakeholder terminology and avoid technical jargon. So whenever possible, you want to be using the same terminology as the stakeholder. This makes communication easier and more effective. Number 5 is use a breadth-first approach to get the big picture of the project before getting too bogged down into details. So when you're gathering the requirements, it's important to go for breadth. You want to understand the requirements at a high level, rather than getting too caught up into the details. The details can be figured out more just in time when you actually start getting to construction or planning and modeling. And that's just what point number 6 is. Developers and stakeholders refine requirements just in time as user stories are ready to be implemented. So we don't need to have the exact details, like when we were writing that user story about adding bookmarks. We didn't have to have the exact details. We didn't need to know what sort of data structure those bookmarks are being held in or anything like that. We just needed the sort of high level idea of what the user wanted. And we can sort of refine those requirements more just in time as we start actually implementing them. Though in reality, the stakeholder probably doesn't care about too fine details like the data structure you're using, as long as it fulfills the other requirements, including the non-functional ones like performance. So number 7, treat the list of features like a prioritized list and implement the most important user stories first. 8, collaborate closely with stakeholders and document requirements so they're useful to all when creating the next prototype. Number 9 is question the need to maintain models and documentation not referenced to in the future. So, like I was saying, Agile is a lightweight methodology. We want to minimize the amount of documentation. Documentation should be just sufficient to get us on to the next step. For acquiring documents and diagrams and things like that, and we're just going into a filing cabinet and no one's actually going to be looking at them at a later stage, there is no point into creating them. So we should really question why those are being created if we're not going to be referring to them in the future. And number 10 is a big one, is ensure management support for the stakeholders and resource availability during requirements definition. Management sort of pulls the rug, drops their support for the project halfway through, it's not going to end well, and the whole thing will be for naught. So before we even get started on the project, we need to make sure that there actually is support for it in the more longer term. Another thing I should point out is that stakeholders may not actually know what they want. They might not know what requirements they need up front. They might actually need to see the user stories they come up with implemented and running to know if it's correct or not, if what they specified is actually what they wanted. Again, this is why it's so important to have the incremental method with prototypes being developed, so you can actually put something in front of them so they can see, is this what I wanted? And how can it be changed to better fit what I wanted? So we really shouldn't expect our first set of requirements to be fully correct. So after requirements engineering, we then move on to design, specifically architectural design. So there's a few elements of agile architectural design. This is specifically the design for the prototype. In this case, the first prototype, because we're still starting the cycle. And those are focus on key quality attributes and incorporate them into the prototype as they're constructed. Keep in mind that successful software products combine customer visible features and infrastructure needed to enable them. So the big thing there is our prototype should have two things. They should have features that are visible to the customer, like GUI. That's very easy for them to test and accept and interact with. But they also need to have the sort of supporting infrastructure and backend that actually drives those features. Agile architectures enable code maintainability and evolvability if attention is paid to architectural decisions and quality issues. So what we mean here by evolvability is we want our code increments, our prototypes, to actually be something that we can build on in later cycles, not something we have to throw away. So that means while designing the architecture, we have to be thinking forward to the next stages of the project. So managing and synchronizing dependencies amongst functional and architectural requirements is needed to ensure evolving architecture will be ready for future increments. That's sort of what I'm getting into, but it also means that we have to keep sort of the other requirements and functional ones in mind, sort of like performance and things like that. We could implement a feature, but if it goes extremely slow, it's not going to be that much help to us. So next up is going to be estimate required project resources. And when you're talking about project resources, the main thing we're talking about is time. How long is it going to complete this prototype? So with agile methods, it's usually pretty hard to estimate time, at least much more harder than the prescriptive models, which can have a predefined amount of time set for each activity. So teams should use historic data to develop an estimate of the number of days needed to complete each user story known at the start of the project. So in this case, historic data is mostly past projects, how long it took to complete them, how long it took to complete similar user stories in other projects. Number two is loosely organize the user stories into sets. They'll make up each sprint planned to complete a prototype. Notice here we're sort of getting some of the agile methodology of XP method, which dealt with user stories and also sort of organized them into sets to be developed in the next sprint prototype. Number three, sum up the number of days to complete each sprint to provide an estimate for the duration of the total project. So that makes sense. You have a list of user stories, you know how many days each one's going to take to implement, you put them together based on what you're going to do in the next sprint, and then you sum them, and that gives you a rough idea of how long it will take. Of course, there's going to be other overhead like integration, things like that. Then, the key here is that you revise that estimate as requirements are added to the project, prototypes are delivered, and you start getting a better idea of how the team's function. So you can calculate a better velocity for the next sprint based on how the last one went. So now, after we have everything planned out and estimated, we can start working on constructing our first prototype. And we have a few guidelines for creating that first prototype. So the number one is transition from a paper prototype to a software design. So what's meant here by paper prototype are things like wireframes or GUI mockups that you might literally draw on paper. This is a great way of presenting sort of a potential graphical user interface to the stakeholders and have their approval or disapproval of that before you even write any code. After that's approved, you go to number two, prototype the user interface, sort of actually make that user interface in some programming language or software. And by doing this, you're sort of creating a virtual prototype. So it's something that runs, it has code, but it's really just the user interface, show the layout of things like that. It's not really taking any input or output or doing anything. Then number four, you want to add input and output to your prototype. So you want to actually register those buttons being clicked, menus pulled, things like that, opening files. And then you want to start engineering your algorithms to actually start processing this input to do something. Once that's complete, you then test your prototype, both unit tests and acceptance tests. And the last key guideline for prototyping is you want to prototype with development in mind. So that means don't take shortcuts. You might be pressured when you're getting close to deadlines and things like that to just sort of not put it the best quality code in, just do whatever you can to get it working. But the problem with that approach is it's going to cause issues later on. Remember, this prototype's going to come back in the next sprint, and you're supposed to be building on it. If you had some garbage code in there, that means it's going to add more time to the next sprint, and it's all going to snowball from there. So when you're developing these prototypes, you want them to be something that you don't have to throw away or significantly refactor. You want them to be things that you can build on for the next sprint and keep building until they eventually become the real product at the end. So after we've constructed our prototype, we now have to evaluate that prototype. So this should be something that's done with the stakeholders because it's their evaluation that's really going to matter here. And instead of just giving the prototype to the stakeholders and saying, what do you think? We want to provide some scaffolding for asking for feedback. So we want to either like use a form or something like that to make the feedback more structured. A good model is sort of asking them to respond with what they like, what they wish the prototype had, and sort of what if. What if it had this feature? So you want some sort of scaffolding to make their feedback more structured and make it easier for them to provide feedback on key things that you're interested in. Next thing is test your prototype on the right people. So we don't want to just have developers testing the prototype because they're the ones that are working with the software every day. They're going to not be a good measure of, for example, usability because they know where everything is, they know exactly how it's laid out, and things like that. Sort of a good real life example of this is again in video game design. So One problem with video game design, with the developers and even the QA testers, that because they are playing the game every day to test out the features while they're implementing it or testing it, they're doing the same thing in that game over and over and over again, that they sort of lose perspective and aren't able to judge how difficult the game is, for example, or how intuitive certain concepts in the game are, because they're doing it so much it's become second nature to them. So, one thing you should do when you're testing your prototype is actually test it with the end users, people that don't have that level of this is my job, I do this every day over and over again to test this. And that's for all types of software, not just video games. That's just an easy example. So, number three is asking the right questions. So, when you're showing a prototype to someone, you're sort of tempted to ask almost leading questions that are going to give you the answers you want. But those aren't necessarily the answers you need. You want to be asking questions that are actually going to help you develop the prototype. Sometimes those are tough questions to ask. And that sort of leads us into number four, is be neutral when presenting alternatives to the users. You don't want to push them into certain alternatives just because that's what you want, or you don't want to get rid of a feature that you spent time on when maybe that's not what they actually want. Might be good for you in the short term if they agree with you, but in the long term, if they're not actually developing what the stakeholder wants, it could be a problem at the end of the process. Number five is adapt while testing. So, in some cases, if there's something that the stakeholder or the user who's testing the software doesn't like, it might be as simple as just changing a simple setting to fix that in the prototype. So, if there's something that you can easily change right while they're testing it, you might as well do that while they're testing because you'll get a little bit more feedback there than having to wait a whole sprint for it to change. And number six, which is pretty obvious, is allow the user to contribute ideas. That means not just what they like or don't like, but also maybe suggestions for how the software could be better or new features that could be added. So after that first prototype is constructed and evaluated, we now have to make a big decision. This is the go or no go decision. And essentially what this is deciding if we're going to scrap the project and end it right away, or if it's worth investing more time and resources into it. This can be a really hard decision to make because, from a developer's team's perspective, they put a lot of resources into it, a lot of personal effort, and it can be hard to decide to scrap it, even if that's what's in the best interest of the users and the company. And this sort of ties into something called the sunk cost fallacy, where because you've spent a lot of time or effort on something, it means you don't want to throw it out, even though that would be the best course of action. So, key here is making that decision. Is this worth continuing on or not? So, there's a few things to consider here. The first is that cost estimates and scheduled changes are proposed based on how that evaluation went with the prototype. Another thing here is managing risk. So, we have to consider risk of exceeding the budget and missing the delivery date. We have to assess that. What's the likelihood of that happening? We also have a big risk that we have to consider, which is failing to satisfy the user's expectations. Are we actually going to be able to make what the stakeholders want? And lastly, number four is to get or confirm the commitment from stakeholders and management to actually providing the resource we need to complete the next prototype. So, based on these four things, we then decide, are we going to go on and continue making and evolving the software, or are we going to decide to scrap the project? So if we decide to keep going, we now have to evolve that prototype. And this really comprises three different activities: evolve the system, redefine the scope, and then construct the next prototype. So we'll talk a little bit about the evolution of prototypes. So the big first step is to collect all feedback and data from the evaluations of the current prototype. We got a lot of that at that evaluation process. And then the developers and stakeholders begin negotiations to plan the creation of another prototype. And part of these negotiations would be what features or requirements are going to be included in the new prototype. Once that's agreed upon, consideration can be given to any known time and budget constraints, as well as the feasibility of actually implementing these things in the prototype within those constraints. If those risks are deemed acceptable, the work continues. And as I've said a few times now, we really need to design to allow for future changes. We want to build on that prototype, not throw them out, because that could be devastating in terms of cost, how long it's going to take. So we have to build that in with our design, is how we're going to build on this in the future. So after we construct a new prototype, we evaluate it again, and eventually, as we're going around this circle over and over again, one of two things are going to happen. It's going to get thrown out and the project's going to end, or the prototype is accepted completely with no more changes needed right away, and it can be considered to be the finished software product. In this case, the prototype becomes a software release. But before it's a release candidate. So release candidates are subject to user acceptance testing, in addition to testing conducted during the prototype construction. So user acceptance tests are based on acceptance criteria that were recorded as user stories were created. And we saw some examples of those in our activity for this week, where we created a user story for bookmarks, as well as some acceptance criteria for them. So those are going to be used on the release candidates to sort of ensure that they actually are fulfilling those user stories. So user feedback during acceptance testing is also encouraged. So these user acceptance tests are both automated as well as manual ones that involve actual end users. And these should really focus on user visible functions as portrayed via the user interface. Remember, user acceptance tests are from the user's perspective, so they tend to deal with front end things, whereas unit testing and things like that are more of the programmer or the developer's perspective. And developers should make changes, but only if these are changes that will not delay the release of the prototype. If the big changes are required, it shouldn't be a release, rather it should go back into the prototyping phase. Changes aren't made, they need to be verified in a second round of acceptance testing before moving on. Be a big issue if you added new issues when you added those changes, and they got into the final product. So we have to test again. Generally, should always be testing after a change. The issues and lessons learned from creating the release candidate should be documented and considered. This is all part of that process of a continual improvement. So we want to not just make better software, but also make the process itself for making that software better. And that will lead also to better costs and time estimates for future projects. But software isn't done at this point. You don't just release software and you're done with it. You then have to enter the maintenance phase. So we haven't talked too much about software maintenance, but it can be divided into a few different categories. First of all, I'll just summarize what maintenance is. These are activities needed to keep software operational after it has been accepted and released in an end user environment. And these fall into these four categories here. The first is corrective maintenance, and this is reactive modification of software to repair problems discovered after the software has been delivered. Next is adaptive maintenance. This is reactive modifications of software after delivery to keep the software usable in a changing environment. Next is perfective maintenance. This is proactive modification of the software after delivery to provide new user features, better program code structure, or improved documentation. And then we have preventative maintenance. And this is the proactive modification of software after delivery to correct product faults before discovery by users. So, in terms of maintenance, the one that you spend most of your time on will be preventative maintenance. That's going to be adding new features and making the program better. But in terms of correcting issues and dealing with bugs, you're mostly going to be doing adaptive and corrective maintenance. So that would be reactive to sort of users discovering bugs and things like that, and repairing problems. So preventative maintenance is more rarer, but it does occur. And this, like I said, with the proactive modification of software to correct for bugs that could happen in the future. Good example of this is the Y2K bug. So what the Y2K bug was is back in the 90s, there was a big concern that some systems, mostly Windows-based, were recording dates as two digits of the year. So like 1986 would be the number 86, 1995 would be the number 95. But there's a big problem with this. Once you get to 2000, it goes 00, which is indistinguishable from 1900. So there's a lot of concern that this would cause a lot of programs to fail. So a massive initiative had to be done to do a lot of preventative maintenance on a ton of different systems to make sure that they were all Y2K compliant or that they handled dates properly. Fortunately for most Unix systems, they handled dates differently. They instead handled dates as number of seconds since January 1st, 1970 at midnight UTC, so they didn't quite fall into that. Now, you might think that's pretty silly. How could we be so poorly forward thinking that we would store years as two digits? However, that probably isn't going to be the last big time related bug to happen. In fact, there's one on the horizon already called the year 2038 bug, or the Y2K 38 bug, or the apocalypse. And what this is the way I mentioned, is that Unix systems, or at least Unix date formats, store the time by number of seconds since January 1st, 1970, midnight UTC. The problem is, however, on 32-bit systems, there's only so many numbers you can hold in an unsigned integer. And it turns out that if you're using 32 bits to store a date, that's going to run out on January 19th, 2038 at 3 a.m., 14 minutes, and 7 seconds UTC. So that's about 16 years from now. Fortunately, most of our computers are moving on to 64-bit architectures, so for a lot of software, this has already been resolved, and a lot of efforts have already been made for preventative maintenance for the year 2038 problem. However, there are a lot of embedded systems out there. Remember, we talked a little bit about embedded systems. Those are sort of software running on the hardware devices that you don't directly interact with, like maybe TV remote control, things like that are using 32-bit architectures or even less. They're still storing time in this way with 32 bits. So if those aren't corrected, and there's going to be a lot harder to correct those on embedded hardware in the next 15 years, we are going to have a bit of a problem. So it'll be interesting to see how that plays out. I know most of you probably weren't old enough to be too aware of the Y2K bug, but at the time it was quite a big deal. There's even like whole nationwide initiatives to deal with it, even people panicking and going into fallout shelters like that on New Year's because they were so afraid of it. So it will be interesting to see how everyone reacts to the 2038 problem. Is it even going to be a big deal? Will the news media even understand it enough to report on it? And we do still have 15 years to deal with it. So it'll be fairly interesting to see how that plays out. Anyway, that's all I have for you this week. Next week, hopefully, we'll be back to a normal format with in class lectures. Once again, sorry for the inconvenience, and I hope to see you all next week.